All right, so let's begin our class. Today we'll talk about the next set of concepts, currying, function closure, and the type system. Basically, we pretty much finalize what goes into the first part, not the first part, the first part of this class and what will go into the midterm. Everything that we learn until the end of this class will go onto the midterm. What we will learn next week will not. Basically, if you want to study for the midterm, just take a look at lecture 1 to lecture 5 and assignment 1 and assignment 2. Those would be a good study material for your midterm. And next week, we'll do a review session. We'll go through also some example questions from last year so that you can see roughly what are you expecting. All right, so for the content today, we'll start talking about currying. Currying is something that relates to performance in the functional language. Basically, what we learned so far, everything is a function, right? So you wait for the input. Whenever you have all the inputs, you run the function. So instead of the parameter that accepts normally something like this, f of n, right? That accept A and B in parentheses. Something like this, right? This is the uncurried version. You have X, Y, and Z as an input. Our combination of X and Y and Z go into the input to your function, and basically your function would check if X is less or equal to Y, and Y is less or equal to Z, and you return the output. Val also would, this is basically do the same thing. You perform sort 3 numbers. You have X and Y and Z, right? As an input, this is a chain. Basically, it's like a chain function. You first take X, then take Y, then take Z. And then you compare if X is less than Y and Y is less than Z. If you want to curry, basically, this is the currying version. Instead of having one single parenthesis, you do this. And the difference here is if you look at this argument, what happens if X is ready and Y is ready? And I'm still waiting for Z. Specifically, if you look at these two sides, wrong circle. If you look at both sides of the function, let's say I know X and X is 2. I know Y and Y is 1. What can I tell about this function? I'm waiting for Z. I don't know what Z is. What can I tell about this function? X is less or equal to Y will be evaluated, right? So in functional programming, whenever you say execute, you change it to evaluate. Basically, you're gonna evaluate X is less or equal to Y, and what's that value? What is that value? Is it true or is that false? It's false, right? So this becomes false. And what happened to false that and with something here? The whole thing becomes false, right? So if you know X and if you know Y, and it just happened that the left side of your argument turns into false, you can basically return right away. You don't even need to wait for C. You know that you don't need it. This is the benefit of currying, right? The currying thing is basically the way you write it in Scala, you break that into different parentheses. If you know the value inside the parentheses, you check if you can evaluate anything in your function. This allows you to kind of pre-compute a part of your function whenever the data becomes available. right? So the benefit, anyone want to guess the benefit? Speed, yes. This is called staging. You can stage parts of your function. You just run it ahead of time. Because you know you have the data, you just run it. So whenever you have the value, you start executing, evaluating that part of your function right away. If you remember from the first lecture, the data flow model, this map directly to the data flow model in a really, really fine-grained way. Basically, whenever you have parts of the function that becomes available, you just run it. You evaluate that part. This allows, one more thing, this allows both the compiler to do more optimization and the hardware to be actually faster. If you're in my computer architecture class, you actually right now studying how to make a computer that follow the data flow model. This is called out of order execution. And this is actually common in every single CPU you buy these days, on an iPhone, or your Samsung mobile phone, on your laptop, on your desktop. The way CPU is built is try to imitate the data flow model. So the benefit of currying is try to also imitate data flow model inside the program. It maps really well with how the CPU works. So it improves a lot in terms of speed. In reality, one more thing that I want to let you know is both hardware and compiler are so good these days. These things, the way you compile, is there a compiler class in MUIC? Out of curiosity, there is? Okay. So if you take that, the compiler class, one other thing I hope that they cover is whenever you have a program and you want to compile the program, the output of your program, the compiler actually look at the way you write the program and they make judgment on your code. Okay, that sounds kind of bad, but it's true. They look at what you tell them. The semantic information, right? Basically, if you compare it to English language, right? You look at the structure of your paragraph and you read the paragraph, you know what you're trying to tell the story to your audience, right? In this case, the compiler is your audience. You write the program, you tell the compiler the semantic information. Compiler will take a look at that and make tons of optimization. These days, if you try to do currying, you might see not a lot of improvement over the non-curried version because compiler actually do that analysis already. They already make that judgment. You look at your code, they look at your code, look at all the assumptions you're making, and already provide that optimization. One thing you can try is run a profiler. Anyone here know what a profiler is? Anyone here use the command prof before? This is in Linux. So profiler is a program that allows you to analyze the performance of your program. And I'm actually glad that I brought this up. Basically, when you care about performance and when you run your program and you're like, why is my program so slow, right? One thing you can do is run the profiler and test. The profiler typically will tell you, okay, this is how fast your program runs. This is how much hardware efficiency you get. Things like, are you using one core? Is the program using multiple threads? Are you utilizing your whole CPU in the most efficient manner or not? This is how much memory usage the program created. So basically, a good profiler would tell you a lot of information. You take that information, go back, stare at your program and cry. No, not crying, but basically you then know where to optimize. You know where to optimize, you know in many profiler, you even know what function is slow in your program. So you can say, okay, this function, the one that recursively call Fibonacci, is the one that takes so much time. So you want to maybe optimize it. The other function that's really hard to optimize, but it will take like fraction of the program's running time. Maybe you don't want to care about that too much, right? It's fine. It doesn't impact the overall performance of your program. So basically, if you want to make your program faster, a profiler is a really, really good tool. One of them is Prog inside this kind of comes with Ubuntu. When you install Ubuntu, you can run Prog with the program. You can actually try it now. Another profiler, if you have heard things like Intel vTune, is one of the profiler that give you a lot of like hardware level information on top of a typical profiler. It would give you, okay, this thread that you just run, it use this much CPU, it consume this much bandwidth. If you look into different functions calls, it would tell you kind of like a breakdown. Depending on how much you want to pay Intel, the free version already give you a lot of information already. And if you're still using the MUIC account, I believe that if you use the .edu as the domain name when you register for that, you can download and use it for free. So maybe you want to try that. It's actually pretty informative and new to many of you, especially if you never heard about the profiler. All right. So now that I go super sidetracked, let's come back to the content of our class. So far, what we assume is the variable that we use are immutable, right? A few of you already asked me on Discord and during office hours about, okay, can I use var to make your variable mutable? And yes, you can. This immutability is good in some cases and it's super annoying in another case, right? What if we want to store a state? What is a state? Actually, what is a state? Can someone tell me what is a state? Or have you heard about this terminology before? In like physics or chemistry, what is a state of a substance? Is it like a flag? It's more, so that's going to be really specific to certain things. Yes, it's kind of like the value of the attribute at a given time. The important. Yes, remember information of a system program. Those two are kind of like the same thing. If you look at an instant of time, if you look at any instant of time, right? A state is, what do you observe, right? For example, if you look at the state in chemistry, like if you look at substance, it can be solid, liquid, or gas, right? If you look at water, depending on the temperature at some point of time, it can be a solid thing like ice block, right? It can be a liquid, which is water. It can be also gas form, right? Which is, what's it called? I forgot. Basically, water can evaporate it and becomes the gas form, right? So that's the state of certain substance. In computer science, a state means that if you freeze the time, these are the stored information of certain things. And in real hardware, you need that concept of state, right? Because you want to run your program over time. So this is really important in the practical sense, especially in functional programming, because functional programming technically has no state. It technically has no state. For those of you who try to do the in-class exercise and the assignment, by trying to have the temporary variable and then do the loop. Basically, you build a function that behaves like a loop. You're basically trying to build a state. Right? Each time you go through the iteration, you are basically modifying the temp variable. So that's not actually what functional programming is built for. Actually, when you want to store a state, instead of having this mutable variable, you then build accumulator. But this is annoying. So one thing that modern functional language give you is they say, okay, we give up. You can use mutable variable and have a state. Basically, most functional language nowadays would offer you an option to have mutable variable. And the benefit is basically you can now keep the state. You can have temp variable. And to declare that is you can use var, var, right, to have a mutable value. Now x is mutable. And with this, you can implement a while loop. For example, you can define this function, right? This is a function definition. It's my own while loop. I take in the condition as an input. My condition is an input, right? What is block? What is this? It's a value actually, but everything in functional programming is a value. So to be a little bit more precise, this is the loop body. So you pass in the loop body that you want to run. It's a function. Yes, it's a function. Basically, it's a function that consists of the loop body, right? If the condition is true, I'm gonna recursively call my own function. I'm gonna pass in block, right? Is the loop as my second argument. I'm gonna pass in the condition as the first argument. Else, I'm done. Any questions about this code block that I'm giving you? Isn't it like a function? Yes, a block is a function. So this is how we say I hate functional programming. I want a loop. This is how I'm gonna build a loop in functional programming. So it's basically it's like you know that this is the goal that you want. You want to build a loop, but there's no road from where you are to the goal. So you go around like different things just to get to that goal. Notice the currying part here, right? Condition and block is curried.
อาจารย์คะ when is the midterm exam midterm exam
When is the midterm exam? Is that the question? Sorry, I like your the beginning of your sentence is choppy.
when is the midterm exam?
When is a midterm exam? So we will talk about this at the end of the class. So stay with me for now. The content of this lecture is related to the midterm. I'm not gonna tell you when is that until the end of this class. Because I want you to not get sidetracked by that and listen to the lecture. Yes, so the unit is like a value that you're not changing. So it's kind of like a void, like I don't return anything. So the code example for this, that's a great question. Let me put it in an announcement tonight, I think. Basically, after I'm done with like my makeup class, the makeup computer architecture class, which is right after this class. So once that's done, I'm gonna put in the code sample and on the announcement, so that you see the how you can build the loop inside functional programming. All right, any more questions? Okay, so let's talk about the next thing called function closure. Have you heard about this function closure terminology in like the basic programming? Function. Okay, so sorry, there's a question about using tail recursion with var outside the inner function. Would it also function the same if you use var? If you use that mutable variable inside, so are you using that inside the inner function? So basically, let me rephrase that. Uh, it should, unless you make another declaration inside the inner function for the same variable. So be careful with the mutable variable, because whenever you see the same thing again, it's not another copy. It's the same thing. So you can't make basically you can't redeclare that variable inside this function closure, which is what we're getting into. Wait, why am I on this slide? Sorry, there was skip slides. So function closure relates to something that we want to allow, right? Communication between different functions. That's why you want to convert a string. Great. Never mind. Okay, let's just go through the actual function closure first. We'll cover that example later, because it's a different topic. Sorry, I didn't sort my slide correctly enough. Let me go to what I just show you later. Let's go through function closure first. Function closure has to do with the scope of a function definition. It has to do with the scope of your function definition. Now that function can be passed around, right? Now that function can be passed around, which is actually related to that slide, basically how you can communicate between different functions. Your body of the function is evaluated in the environment where the function is defined. This is the important part. When the function is defined, what does that mean? What does that mean? It means that if I have a def, basically def f of n, and then later I call f of n, it means that whatever f of n see, you take a snapshot at right at this line. Whatever f of n see would be dependent on what was defined earlier, which is from this point upward. From this point upward. And over here, things that you have right here does not matter, right? Not when it's called. What we actually have a formal terminology of this is called a lexical scope. Right? A lexical scope is a scope where whenever you define a function, what is being used in that function would see the environment previously defined right before that definition. And this sounds confusing, so let's go through some example. So here, let's look at this code. Let's look at this code. Notice that on line 6 right here, right, it's called by value because we use val, right? So t equals to x plus y. And notice that on that line, what is x? X is 12, right? Begin with 11. Then you do x equal x plus 1. So that's 12. y is 4. Why? Because during that, right before val t equals foo of x plus y is 4. Then inside this function right here, right, because you call foo of x plus y, right, the value of x here is 11. What is the value of y? Is actually, if you look at this foo take one value, right, which is an integer, this is the value I'm passing in. What is x at that point? Yes, so x is 12, y is 4, so this is 16. Right? It's from the input, and the input at that point at line 6, x is 12, y is 4, so you pass in 16. Inside that foo, x is still 11. You go back in time because that's when the function is defined. X is 11, y is your input, so y is 16. So this actually return 27. Right? So over here, t equal 27. Any questions so far? Oh yeah, sure. Let me erase. Let me just have this piece of code, right? And I'll tell you how we can reach the conclusion that t is 27. So let me erase everything here. Let me do this. What is the oops pen. So let me build a table, right? What's the value of x, y, c, and t over here, right? What's the value of x in line 1? 11. Yep. And the rest are unknown, right? Because we haven't defined it yet. About line 2, what's the value of x? Again, 11, right? It stays the same. We haven't redefined it. What's the value of y? It's your input to the function. It's your input to the function. We don't know c, we don't know t, right? What is the value of x, y, and c and t on this line? X is still 11, right? Y is unknown because you are outside of foo. C, what is C? You put in 14 here, right? 14 goes into Y here. So this is what? It's 25 because this is 11 and this is 14. So you have 25 right here. T is still unknown. With me so far? Now X become 12. This is unknown because we haven't defined Y outside of that full, right? This is 25. This is unknown. 12. What is Y now? 4. Yep. 25 unknown. Now 12, right? 4, 25. What is T? So this is 12. This is 4. Let me use a different color. Let me change the ink back to red, right? So these two things goes into Y as an input here. So Y is 12 plus 4, X is 4. So basically you then add the two numbers together. X is not 4, X is 11, my bad. X is 11, yes, sorry. So that becomes 27. Okay, that's a great question. So there are two questions that are both good. First question is what I said earlier, the function would be evaluated when with the environment that when they are defined rather than when it's called, right? Foo here evaluate when you call foo, which is in this line, in that line. Function closure means that when I define foo right here, right? Function closure, basically it dictates that x is 11. That's it. Basically, the function closure means that whenever you finish that definition of foo, which is line number two, whatever variable that you use it based on what foo see at that point, right? Y is your input, so that's fine. We don't know why. X is declared earlier, so it takes 11. So does it answer your question? Okay, perfect. The second question is, why would someone ever do this? That depends. That's also a great question. Depend on usage of it. This is actually pretty common if you think about having a bunch of functions, right? Having a bunch of functions that are defined, and sometimes you rely on previously declared variable. This particular example sounds useless, and it is useless. But in reality, sometimes you would have to define a function and you rely on previously declared value. Function closure gives you a rule of law. Basically, it's a rule of law that say, okay, if I define things here, whatever you refer to has to be whatever that particular snapshot in time that my function see, not in the future. And that's all. So hopefully it answers your question on why would someone ever do this. It's the necessity. Sometimes you have to write a function that way. Sometimes, in all cases, these kind of things that are really convoluted, it only will happen on your exam. But be mindful that sometimes when you build a program, right? When you build a program, you need to rely on previous state. Function closure just basically tells you what state are you looking at. That's all. All right. So in lexical scope, using the last example, right? Somehow the function foo would take the value x in the old environment, right? Which means that fundamentally the execution, right? The execution will keep the old environment as needed, right? So it means that whenever you have function calls, actually that's an awesome question. Isn't it taking in outside value side effects? So are you talking about the side effects, right? So side effects means there's an environment part where you declare different variable, and those are not side effects. Side effects are something like I'm running my function and somehow I throw exception. Those are side effects. Those are something I don't speculate that I'll see. Or I run the function and the user type in something on the keyboard. Those are also side effects because you need to print something on a monitor, right? So those are something you cannot tell, but it's a side effect of the function that you run. This, you already know the environment of the function. You know what is x from the example. Right? So those are not side effects. Those are something the compiler can clearly see. It knows the value of x. It can assign x to 11. So does it answer your question? The way I reason about side effects are something that if you look at your code, there's a chance that something random happened and you don't know what that thing is. Those are more like the side effects of your function. If I look at the code and I can deterministically tell what will happen, that's okay. That's not side effect. So a function definition over here, now it has two parts, right? The code, which is basically the function you write, right? And the environment, the point of where you define the function. What is the value of different variable? And that environment is what we call the basically function closure. You teleport in time back to that old environment, right? And you cannot manipulate this later on. You cannot manipulate it in the future. You cannot change that old environment. Which is also why it's easy also to prove the correctness, right? Because you can't manipulate it. It ties to immutability concept. So here are more example. My question, I'm going to give you like 5 minutes on this. What's C? So I'm not gonna tell you the answer now. I'll let you work on this for maybe 5 minutes and tell me what's the value of C. All right, so someone got the answer already. Is it 7? So let's go through this and see if this is 7. Basically, bar, you look at this because that's when you define bar. That's the last time you define bar. So that's the version of bar you're going to use. Then you call make bar too. What is make bar? Make bar is this, right? Make bar take one variable, which is y. So this value 2, let me use a different color. Value 2 here goes into y, right? This x is 1. So basically what you do here, t is 2. With me so far, right? T is 2. Because x is defined right here. So that's 1 plus 1. Or y is x1. Basically, if you look at make bar, go up in time and see where did you define x. But that's later. When you define make bar, you see that x is 1. Then make bar return this function. It returns this function. It takes in c, which is an int, right? And it return what is t? What is t? T is 2. What is y? Y is also 2, right? Because you put the value 2 here, that's your y, and then plus c, that's your input, right? So this is t, this is y, this is still unknown because that's your input. You define y is 1, doesn't matter. You already have the value for y. Then you do bar of 3. What is bar of 3? You replace c with 3. So basically this becomes 2 plus 2 plus 3. And that is 7. So any questions so far? Or if you want me to do and go through this again? Any confusion? Let's clear it now before we move on to a different topics. Okay, why is x1? That's a great question. Basically, again, if you look at the point in time these lines happen, right? You basically transport to that environment. That environment have not seen this line yet. Like you don't see it. So you don't see val x equal 4. What you see is this, val x equal 1. So when inside make bar, whenever you see x, you replace x with 1. Because val x equal 4 happens later. Which one? The bar equal make bar 2, right? I'm trying to understand your question. Basically, you said val c equal bar 3. Is 3 assumed to be c by this declaration? Yes. Basically, bar, right? Bar without any parenthesis is this equal to, it's a function that take in integer, and it would replace your input to 2 plus 2 plus c. Bar of 3, right? Bar of 3 would put in the value 3 right here. Replace any instant of c with 3. Exactly. The function doesn't see anything else after the declaration. When you define the function, you look back and take whatever you see. It take whatever you see. In this case, make bar return a function. It return a function. It's a function that do 2 plus 2 plus whatever input variable you put in. Is x equal 4 automatically redundant? It's not redundant. You redefine, you remap x. Basically, you remap x to 4. But by that time, the definition that you say earlier, the make bar, x is already 1. So it's t is 1 plus 1. All right. So let me give you a different concept, right? So this is like basically the inverse-ish, right, of lexical scope. Whenever I say dynamic scope is basically in this case, the environment that you use when the function is called. So in the earlier example, x become 4. So from this, okay, so there are two questions that are both asked, I think, privately. So let me tell everyone else what was the question. The first question is, if make bar is defined after x is 4, then yes, x become 4. After we redefine, so the second question is, after we redefine x, if we redefine make bar, then yes, x is 4. So hopefully, does it answer both of your questions? Yes and yes. Awesome. Yes, exactly. So the follow-up question is, with dynamic scope, in this case, x is 4. Yes, because that's when you call the function. This just happened to be a lot of research that show more benefit of using lexical scope. But because these are research, it's not haven't been proven always strictly better. That's why we still tell you there's another thing called dynamic scope. Maybe future research give you a totally different results based on hardware compiler technology. Basically, just be aware that there's this thing called dynamic scope. right? Dynamic scope, which is you evaluate the function whenever you call the function, not when the function is defined. So you might be curious, right? There's already a question actually. Why would someone do this, right? Using function closure, it means that function can be evaluated at multiple places. Not evaluate until the function is called dynamic scope. Evaluate every time the function is called for the function body, or you have variable binding, right? You evaluate expression when the binding is evaluated, and not every time the variable is used. And to avoid confusion, you can store evaluation inside the function closure, and I'll go through the example because this sounds confusing. So here's the example. You have a function that look at the list of string. You compare, you basically compare the length of the string and see if the string inside the list is longer than your comparison string s. Your comparison string s. And the function body basically do the filter, right? It basically filter out whatever in XS, the list. You just filter out the string that's longer than S. And let's go through this example. So over here, you know that you're gonna call s dot length multiple times, right? Multiple times, and somehow, what if you redefine s? Right? What if you redefine s and you use dynamic scope? So those are the two requirements. If you use dynamic scope and redefine s, the way to fix this and to make sure that this is the exact string s that you talk about, use a temp variable in the middle. These basically force thresh length to be s dot length by the time function is called. Basically, once this is called, the value is bound, right? The value is bound. And basically now you can use anonymous function. Basically, it's a function that is defined like this with the equal and greater than sign. Those are anonymous function. You then compare with exact length, and that's it. These basically force your threshold length to be that instant of s dot length. Another example is Fibonacci. So this is a typical Fibonacci function, right? What is this? Can someone look at this code and tell me what does this do?
The Fibonacci program.
Basically it's create a Fibonacci function. So it make a Fibonacci function. Your input is a number, and your output is the fib of t, right? Fib of t, which is whatever input you put in here, you add x to it. So if I do this, val t equal make fib of 10. It means that I'm gonna have, if I call t of 11, that becomes fib of 10 plus 11, right? And you might have noticed this case, you will have to call fib of t every single time. And the environment of this, you have to keep it. You have to keep what is t. There are two things, right? The runtime, basically whatever maintain the state of your program need to keep the value t forever. Then you need to also run fib of t all the time. To make a better function, you can use val, right? Fib t. make sure that whenever you call this function you created, you don't have to re-evaluate Fibonacci, right? So these are the two things that I want you to try. Basically, you first make fib for 45 using the two version, the better version and the default version. Compare the execution time. So let me ask you this. Which one do you think is faster? The first version or the second version would be faster? The second version is faster. Why? That's a way better in it. Yes. Thank you. So there's a private answer through the private chat saying because we are not calling each time, we are not calling Fibonacci of 45 all the time. We only call Fibonacci of 45 once when we define the function. And yes, because there's a better in the function name. Maybe I should have an exam that I make a worse version of the function and I call it better. And I'll see if you get confused. Okay, so before we dive into the type system, let me go back to the slide that I said I have it in the wrong order. One thing I want you to realize is there's a built-in function inside your inside Scala called for all. Because we talk about loop, basically, I want to make sure I talk about the loop before talking about this. It's a recursive data type. Oh. Okay, that's a great question. So the program would know when you're calling the same number, right? You bind it. So let me just write it here. Basically, you say better full 45, and then the same thing for 60, right? What you have is then you have to bind this to something else, right? Val T and maybe T2, right? It means that whenever you use T, you're gonna use fib of 45. Whenever you use T2, you're gonna use fib of 60 because these are still function. Better full fib is still a function, right? But it means that you don't have to evaluate fib of 45 and fib of 60 every time you use T. Does that answer your question? Okay, awesome. So for all inside Scala, it's a pretty useful tool. That's why I introduced it here because you might want to use it, especially if you want to use a loop. X dot for all of P. This is the same as this function. P takes a type, return Boolean. X is a list. So this is a list. P is a function that takes in a type, the same type as the element of X, and give you Boolean. This is the same as you apply. Basically, you apply P to every element of X. Right? You apply P to element of X, recursively call for all for the rest of your list. Example is with our old friend expression type, right? What if we want to map expression to certain function f? This is what you can do. You can then map, right? Here, call the map function, right? Where you define it, and you use a pattern matching. If you want to, so from this example, we are not using for all yet. If we want to check if all expression are positive, see if we want to check if all expression are positive, then you apply for all, right, to element. This is a function p, check if e is positive, and you apply this into the elements. If it's a constant, you apply p of x. Otherwise, you apply recursively apply to elements e or e1 and e2 if they are sum or product. One more thing, except for all. So this is for example, but not on list, right? This is on our own data type. It's an expression. So basically, you can apply for all using a list, and you can build your own for all function. This is how you build your own for all function. Another thing I want you to know is communication across functions. So let's say we want to do this. You want to check this string, convert this to a list of Boolean. True, false, true, false, true, false, true, false. What happened here? What is the bug that you are going to run into? You have typos, right? These convert to something you don't know what to do. These two things. So the function signature of this is you have a string as an input and you return list of Boolean, right? And what you do here is to split and then map, right? Map function to Boolean. And the problem here is if you see this part, right? You have a string that comes in here. This might be okay, but this is not okay. It's a typo, right? So you can't have that typo. So when you communicate that, hey, there might be possible bug in my input over here with this function signature, right? With the same problem here is exactly, you need to communicate this problem. So one option is to make it more expressive using option type. The second option is we can draw an exception, right? The second option is we draw an exception. We cover both topics, right? So we basically can either throw an exception, and this is how you draw an exception. You convert to a Boolean. You have the option type. It's an option of list of Boolean. It's an option of list of Boolean. If there's an illegal argument, which is some typo in your string, then you throw an exception. Otherwise, you do it normally. You convert this into two lists, into a list of Boolean, and then you return an option, sum of entry. Otherwise, if you catch the exception, you return none, which is also an option. This way you can detect that there's something wrong with your input that's allow you to communicate across different functions. So that's it. Those are the two side things that I want you to learn before. It is a tool that you can use in your program, essentially. So now, before we switch to a different topic, which is the type system, is one of the core topic inside functional programming. Let's take a break. So let's do a 15 minutes break. It's already been an hour. We covered a lot of things. Okay, so that was a question about the early example on the exception throwing. So over here from this example, there would be a none, not at the end of the list. It's a sum of list or none. Basically, this is option of list of Boolean, not list of option Boolean. Does it answer your question? So basically, you return two possible things, none or sum of list of Boolean. You can make it your way too. Basically, in this case, you would then return, I guess, list of option of Boolean. In this case, basically it's a list of either none or sum of true or false. It's your design decision, right? But over here for this particular example, it's none or sum of list of Boolean. Okay, so before we dive into the type system, let's take a break. It's 10:09 at 11:09 right now. So let's meet back around 11:25. Is that okay? 15 minutes break before we come back. Go get coffee. Make sure you are awake because the next topic is important and it's kind of like the last thing we learn before the exam. Okay, so let's do a 15 minutes break. We'll see you in a bit. All right. Okay, so it's 11:25. Let's continue on into the type system. So you have seen these many times, and you might by this point be annoyed about your assignment whenever Scala complains that you have the wrong type. The type system has a really good benefit where it basically this whole system allow you to predict you as in the program to tell the prediction of the outcome of an expression and its own property, right? Basically, these convert this particular information, the outcome of an expression during the compile time, right? You compile the code and you know exactly I'm expecting an integer, I'm expecting a list, I'm expecting an option. The expression, like for example, if the expression has string type, it means that eventually this evaluate to a string. What you can do then is compiler would have more information. You can make more assumption during the compiler phase. These also allow other programmer who look at your code to also make more assumption. Basically, these give you more information on what are you expecting out of the function. So you can define a new data type, right? In Scala, we went through multiple of these examples already, right? On how we define a class, define a trait, or define an object. Right? Class name, trait name, and object name. What are the difference between these three things? What are the difference between these three things? Can someone tell me what are the difference between an object and a class? What's the difference between an object and a class? Object only have one instance. Yes. So basically, object is a singleton. So these three things are different. A class is a class as you know it. A trait means basically a trait is similar to you define a type with some, I guess, some traits. And it's not a singleton thing. You can use multiple expression. For example, in classes like expression, use the trait. Right? You can also use the type keyword. Type, my type. Basically, now it means that I'm defining a new type that equals to something. So after you define a type, using one of the four different things you can do, a class, a trait, an object, or a type, right? You can then utilize this newly declared type. So if you define a new class, you can do x colon class name. If it's trait, then x colon trait name. Okay? The colon means that the colon basically specify what comes after these variable is a type. And if you use a type to define it, basically now then x colon my type, right? So the dot type for an object, this is a little bit different than the rest of it, the rest of these four examples, because the dot type allow you to distinguish between a class, which is a type, and the object as a singleton thing, right? Basically, if you use an object, don't forget to use dot type. And these are the rules and constraints of a type. Like whenever you define a type, it allows you to assert certain rules. There are generally two kinds of rules, upper bound and lower bound. A less colon B means that in the type hierarchy, A extend B. A extend B. A greater colon B means that B extend A. B extend A. Right? So let me be a little bit more specific. Whenever I talk about the upper bound, right? Let's first make some nested declaration on different types, right? So the first type you're defining is animal. There's a type called animal. There's a type called pet. And whenever you say class cat extend pet, it means that cat now extend whatever we define as pet. In this case, what is more generic, a cat or pet? Which one is more generic? Which one is more narrow? A cat, yes. So you can say that the upper bound in here between the cat and the pet cover more than cats, right? Pet would cover the universe that's bigger than cat. You can also extend dogs from pets, right? From this example, and you can also then extend lion from animal, right? So given this example, the upper bounds tell you, right? The upper bound tells you what belongs to a part of what else. What belongs to a part of what else. Let's create, for example, let's create a kennel to house your pet, right? And let's go to a bad version of this. I say class bad kennel. I text in the input, and then I define pet, which is your input, to equal to P. P as your input pet. Why is this bad? Why is this bad? And what's the difference between this and this version? Why is the second version better? Why is this second version better? Anyone want to take a guess on why the second version is better? So what does less than and colon means here? What does the capital P, the type capital P, has to conform to? What does it tell you? What does it tell you? Let's see, second take is type pet. Oh, yes, exactly, yes. So that's the correct answer. The second version can take in a cat. Let's basically say I want to put a cat in a kennel and use the first version. Scalar would yell at you saying, hey, I know what is a cat, but cat is not a pet. It's not exactly the same thing as pet. Second version tells you that as long as whatever data type that I have that extend pet, right, which is cat, dog, right, these are all valid and you can put that in the kennel. So you can do this dog kennel and just create a new kennel that keep one pet, right? And it make sure you can do this. It makes sure that you can't just put a lion in your kennel because lion is not extending from pet, it's extending from animal. So you got message? Any questions so far? So this is not doable because you don't know if cat extend pet. You need to specifically tell that the type P is okay as long as P extend from pets. There's also one quick thing, there's also an infinite type. So that's any and nothing. Right? Any and nothing. This is essentially universe. And this is empty set. And whatever you do is between these two things. So there's a limit to the upper bound, which is any. Let's look about the lower bound. Lower bound is basically a type selected, right? The type that you select is equal or the super type of the lower bound, right? Here. So list of int become the lower bound. B will be something bigger than list of int. Think of it this way. Lower bound tell you the lower limit. So whatever you're dealing with is bigger than that. Upper bound means you know the ceiling, the upper limit. So what you're dealing with should be a subclass of that thing. So over here, right, this traversable is bigger than the list of int, right? List of int is more restricted, it's more narrow. Traversable is basically a collection of things that you can go through elements by elements by elements. So this new type B is conforming to the lower bound. If you say B has list of int as a lower bound. Okay, that's a great question. So what if something extend cat or dogs? Would that be passed down as the upper bound of pet? Yes. Yes, because you inherit I guess you inherit the type, right? It basically extend cat, right? You can say domestic short hair, American short hair, Siamese, like different types of cats that extend cats. There still be extending pets. So when you do the upper bound, you can still put those things in the kennel. And over here, when you do val x, like val x, which is a new type A that have the B, a new class A that has a type B that is traversable, this is okay because traversable is bigger than the list. It's more broad, right? It's more broad. So our rule that say B has to be at least as narrow, at least as broad as list of int. This is okay. Then you can use something like this. Obviously, you can use a list, right? Because it's the same type. Then you can use a set. Because set is traversable, basically. Set is also traversable. You can go through your set and you can pick, okay, that's one, that's two. How about this? Is that okay? It's not okay, actually. The reason behind that is set is a little bit more specific. It is a traversable type, but there are certain things in set that's different from a list. There are certain things in the set or the property of the set that doesn't exactly conform to what list is doing. So this is not okay. It would fail. It would fail specifically because of our rule right here. So now that we talk about the lower bound and the upper bound, let's talk about parameterizing type. So let's look at something we've seen before, right? You parameterize type T right here. This is called parameterizing. You say T is a type. I don't care what type T is. It's a parameter. It's a parameter. So this is basically exactly what I just do. You are giving a type parameter T. Any questions so far before we move on to what can we do with this parameter? Okay, so now assume there's no question. Now we define T. Let's tie this back to the animal, pets, kennel, dogs, and cats, right? So we have a kennel name, and the function basically return a string. I just want to name the animal, right, and the kennel name, and this is the function. Any question about the function declaration? It is basically should be pretty straightforward. You put in the animal, and you got in back the name. And let's say we want to create the same thing for pets, right? We need to do this. We need to say type T here, the type T that you use, because you don't want to specify what type of pet you're doing. It can be a cat, it can be a dog, it can be just pet. I don't know what the heck is that pet. It should be still be defined as a pet. It can be a parrot, bird, definitely, hopefully not lion or like tiger, right? What you do here is you parameterize and you put in the boundary saying the type T need to conform to pet. It should be a pet. That's what this particular statement is saying. Type T need to conform to pet. And this is a concept called variance, right? The definition, the form. So let me go to the formal definition. The formal definition is this: variance is the ability of the type parameter. This is one word, type parameter, to vary on a higher kind type. Higher kind type means that you look up into the possible type. Those are the broader type. So we can say that C of A is a higher kind type if C of A is said to conform to C of B. If you can assign C of B to C of A with no errors, basically you can assign a function. You can assign a function called C. C is a function. If you can, give me 10 seconds. There was some loud noise outside. Let me check what my cat had done. I'll be right back. All right. Maybe I should put my cat in the kennel. Let's come back to the class. I'm sorry. When you talk about the variance, C over here is a function. It's a function on B and A. If you can apply C on type B and also type A with no errors, it means that they are variance. There are 3 types of variance. Invariance means that if A is the same type as B, C of A will conform to C of B. This is pretty obvious, right? If they have the same type, they should conform to each other. Covariance means that if A conform to, not conform, if A is a higher type than B, it's a covariance if I can apply the function C of A, and also would still conform to if I apply the function C of B. Contravariance is the inverse of that. And with this definition, I know it looks confusing, so let's go through an example. Let's first talk about covariance. Covariance, let's say I have a list of cats. A list of cats, obviously, is a subtype of a list of animal, right? So if I look at function C that return a list of cats, it's a covariant if you have a function that function can also return a list of animal. Contravariance is a little bit more counterintuitive, right? It's a little bit more counterintuitive. It's a parameter for a function that returns a string that given a cat, you got a string. And then that same function can also return a string if you give the animal. Now you're looking at a bigger size thing, right? This is contravariance. My bad. Oops. This is basically the reverse of covariance. It means that the function can take in the cat, and it also can take in the list of animal because I just want to print the string, right? So it works for a list of cat, and I can tell that this is also work with anything bigger or broader than a cat. Covariance is more like if you have a list of animal and this function works on animal, I can tell that, hey, if I have a list of cat, it would also work on a list of cat. Any questions so far? Any questions so far? Okay, so how do we define covariance and contravariance? So be aware that we are not basically what we are telling over here is basically we are telling scalar that certain type is a covariant of another different type parameter. Give me a minute. I'll be right back. Yes, I can repeat that for sure. Let's do the example, right? I have a function. The function take type parameter t. I can tell that t is a covariant of something else. It means that if I apply that function, and let's say the function works on the list of animal, the covariance tell me that it should also work on a list of cats. Because animal is a more broader term than cats. So that's the first thing. That's covariance. If I have a function works on the list of animal, I can tell scalar, I can tell the program that this function should also work on the list of cats. So that's a covariant. Contravariance is something like this. If I have a list of cats, I can tell the computer basically through my program that this function should also work on a list of animal. basically you specify a narrower type and you basically tell that whatever type parameter here should also apply and works. The function should work on anything broader than this. That's a contravariance. So does it, hopefully does it make it less confusing here? Covariance just tell that this function should be applicable to something narrower. Contravariance tells that the function should be applicable to a type that's broader. Invariance means that it should apply to the same type. So that's hopefully is obvious by itself. So here is how you can define covariance in scalar. You use the plus sign. List plus t is one example. Define contravariance is the minus sign, right? List of minus t. And here's the actual example from the cat kennel and animal. Let's say I define the two types of kennel, the kennel that holds a cat and the kennel that holds a dog, right? And you say, I want to get the name, right? The function getName takes in a kennel of pets. You realize that this is a different type. You have pets, dogs, and cats, right? You have pets, dogs, and cats. This will not work. This will not work. And can someone tell me why? Can someone tell me why this is not working? So the exact reason why this is not working is we haven't tell scalar that cat is a part of dog, is a part of pets, and dog is also a part of pets. And the function should work on the getName, right? Basically, whenever you write a program, be aware this is kind of true whenever you want to get the most out of your program that you write. The compiler, basically they will take a list of your assumptions that you're telling them, and it would optimize the code based on the assumption that you're telling, basically the things that you tell them. The language, right, provide you the ability, scalar provide you the ability to tell that, hey, cat can work with the function getName because cat is a part of pet. So you can parameterize this. Anything missing here is basically telling that there are variants inside these three types, cats, dogs, and pets. So this is how you fix it. This is how you fix it. You then say you have a class kennel. You say that P, it takes in the value P. P is covariant of pets. Whatever you apply to pets, anything that is inside the type pets should work on this class. That's it. Any questions so far? Basically, these parts tell scalar that anything that is a subtype of pet, such as a cat or a dog, should be able to use this class. Basically, that's the key. When you do plus P, it means that this conform to pets and they should be able to use it. It's a covariant. Oh, you mean this P equal P part? This part, right? It just basically P, the lowercase p is your input. What you want to do here is to assign the capital P to be P. It's just an assignment. Sorry, I should change the name. It's confusing. It's just a variable name. Yeah. All right, so let's use a binary tree and use a binary tree as an example. What is a binary tree? Let's do a primer on data structure. What is a binary tree? It's a tree that have left and right leaf, right? Basically, you have left and right parts of your tree. Yep, a tree with exactly up to 2 nodes. You can have one leaf as well. So basically, we can make the binary tree a little bit more compact. So we have the example back in lecture 3, I think, on how we use in-order traversal and pre-order traversal on your in-class exercise. So let's create a filtered binary tree of T, right? It's a type. This is actually have to be plus T because if you want to create the leaf or binary tree that consists of nothing, I want this to be passable, right? Passable as any type T. What I mean by this is I want to treat the leaf as the same object as the node. In that way, I don't have to rely on none. Basically, I don't have to rely on a different object called a leaf, right? I just realized I have a typo here. Leaf, not left leaf. I want to make sure the leaf is passable and understandable by the binary tree without creating something like this, right? Without creating something like this. And then the node, this is annoying because you parameterize the tree, but you don't understand what is a leaf. So let's do this by, this can be easily fixed. This can be easily fixed by changing this into plus T. That's it. CU is kind of like a private. Give me 1 minute. Let me double check with if there's anything else with the CU thread. Yeah, so it's kind of like a private, but private within the same file. So other files cannot use it. It can only be accessed by that file that you're working on. So it's kind of like a special type of private in a sense, right? It's not by the program and the program namespace wise, but it's a file system based thing where you look at a file and the CU thread can only be accessible by function defined in that file. So hopefully that answers your question. Okay, so let's create your own function. Let's say we have function f that have type A create type B. It means that what we learned so far is it might be okay to pass in a wider range, right, of A and still produce an output that doesn't really exactly use our properties of B with the fact that we have covariance and contravariance, right? If, for example, here is a pet, this is a string, it might be okay to also do cat into a string. This is what I mean by the sentence here. What if you want to create a function that applies the argument? For example, I have my function that have the argument and the return type, right? And I just want to apply the function with the argument. And so I want to apply the function with the argument. So this is what happened. My function. Let's assume this is a function box. Your input is argument. You return the result. This is the apply function. You apply the argument, you return the results. The argument is the type is arg. Return type is return. What's wrong with the code below? What's wrong with the code below? I basically have my function. I apply the function with input as sequence of integer. I return double. And here, the return is basically you put in the argument, which is sequence of integer, you sum them together. What is the problem here? The hint is actually with how you define my function in the first line over here. You have list of int, right? And you have any type. You have list of int as your argument and any as your return type. But when you actually use it, you said this has to be a sequence of int and this has to be double. What is the problem here? It's type mismatch. Yes, exactly. If you run this, it was a type mismatch. Why is that the case? You haven't established the relationship between list of int and the sequence of int. The same thing goes for any to double, right? So it's not safe to run this code because you haven't tell the program, you haven't tell Scala to specify what to do with this type mismatch. Is it okay to apply this to sequence of int and return a double? You haven't said that. So if you want to fix this part, what you need to do is to make the argument contravariance and return type covariance, right? And this is how you fix it. Just that. My function, contravariance, argument, return covariance. So you can then do val f equal my function. It takes a list of int and any. And this is okay. I can now use sequence of integer because it's a covariant, right? It's a covariant. List of int is smaller than sequence of int. List of int is smaller than sequence of int. Any is bigger than double. Any is bigger than double. What we define right here is basically tell that the first argument is okay to be something smaller. The second argument is okay to be something bigger. Any questions so far? That's a great question because any is kind of like the universe, right? Any is kind of like the universe. So if you want to specify something smaller than any, yes, you need to make sure you tell the program it's a covariance. A covariance is something smaller. So yes, you should have to use covariance. So the question is, when using any, do we have to always use covariance? And yes, everything is smaller than any. That's why it's a must to some extent. Just you need to specify it's a covariance. If you don't specify that it's a covariance, Scala cannot guarantee that the function would work, right? All right, So let's talk about dependency. What is a dependency in general? What happens if I say A depends on B? What if I say A depends on B? In English, it literally means that we cannot do much without A. Right? We cannot do much without A. Dependency in computer science means that if you want to compute B, you need to know A. Why can this be useful? And the next question is, can we manually insert this dependency? The first question, why can this be useful, is again, we add more semantic information. You add more information to the program. The program has now more information for the compiler and the hardware to optimize. The second question, can we manually insert this dependency? The answer, because we are learning about it, yes, we can. This is called dependency injection, right? So if you are taking software engineering class, this might be something you've heard about, the word dependency injection. Basically, one object supplies the dependent items to another object, right? So basically something like this. Object one gives something to object two. It gives you the flow of information. Object one will produce something for object two to consume. In this case, it means that why can't we decouple, right, the actual implementation away from the abstraction, right? So this sounds confusing, so let's use an example. The use case is, let's say I assume that there's a class X that needs a database connection. And in Scala, you can run the code below with the database connection name in the string, right? So you want to establish the connection to the database server or database repository. You notice, right? These create the dependency, and this dependency is tightly coupled to the fact that there has to be that DB. There has to be that database with that exact name, right? You need that repository, and you cannot change the name. You cannot change the name of the repository, which is kind of like, it's okay, but it could be more powerful. What if you want to change the name of the database you connect to? Right? Dependency injection aims to decouple this dependency. It aims to decouple this tie. I need to know the name before I get the database connection. Dependency injection tells the program that, hey, I know that I need to connect to a database. I know that at some point I will provide you the name. It tells you that additional information that I will provide you the name. I'm going to implement this later. I will implement the database later. That's also fine. And then once I finish that, I will tell you the name. So you might have a question. Isn't this the same as the abstract class, right? The inheritance and interface. So why can't you just keep extending this? For example, you have trade fooable, right? The function is it will print this is an ordinary fool. So if I create a code that depends on this fooable, such as something like this, I already defined foo, right? And then I know that I'm going to have another string called bar that extends fooable that print bar called foo. This is an ordinary foo. And you can use it in the main function by doing this, right? The problem here is this is specific to this one implementation of fooable, right? This is strictly defined. It will be tied to this particular fooable. What if I want to change it? What if I want to change it? This is where dependency injection comes into play. Here, this will not compile. Let's say you want to use the width keyword. right? So this is the code. Bar using fooable with fooable. The problem is this will not compile. The reason this will not compile is you doesn't give you enough information about what is fooable, right? So alternative solution is over here. You haven't defined, basically you haven't defined what's fooable. Okay? One solution is, well, you use an abstract method. Abstract by using fooable, and you tell that, hey, there'll be a function called foo, which is a fooable type, and you call this, right? And you then extend it. And this would get messy. Basically, as you keep extending different version of fooable, different version of bar using fooable, this is going to make your program messy. So there's a method to apply dependency injection. We call this baking a cake. So we can decouple using a baking method. Basically, it's a self-type annotation. So this is the first thing you do. You say, hey, there's a trait called fooable. There's a trait called fooable. There's also another function called bar using fooable, and this is a self function. This is basically has a fooable function. These functions do this. Anything that come after this sign can use method or variables of fooable. It can use the method and variable of fooable. It basically tells the program this function, this, right, has the type fooable right here. So anything after this point knows what is fooable. Anything after this point knows what's fooable. So with this, if you have a trait called trait, we basically declare that that class depends on trait. That class depends on trait. And this is different than using the keyword extend, because extend is really type specific. Like you need to strictly have the exact type. Self annotation just say this. I'm just saying I'm declaring whatever goes into the ... which is right here. Whatever goes to the ... will extend the trait. Will extend the trait. The keyword is will. Sometime in the future, it will extend the trait. It doesn't have to do it yet. You doesn't have to actually extend it yet. You tell the program eventually something will extend that trait. It means that this extension has to conform to a trait. That's why we call it baking, because you know that eventually you get a cake, but something has to do the process of baking that cake. You're telling the program eventually there'll be a cake. So here's an example, right? Let's say you have a service, and the service just give you a string. Then you define two traits. You have a default service and a luxurious service. And it print two different string. The default and exclusive, right? Then you have another class. Notice this arrow sign that say it extends full service. Full service is defined here. It means that whatever I put into this part, I'm using different color. Let me use blue. Whatever I put in this part, conform and no full service, which means that if you type in full, you get a string. If you type in full, you get a string. Then you can create a new variable, right? The default and the better full. that use different service. Over here, the keyword width, right? The keyword width basically it ties the definition, the default and the luxury version full with the class that you defined earlier. With the class that you defined earlier. You can use it this way. Basically, you print bar with default full, you're gonna get default full. If you print bar with better full, you're gonna get exclusive full. Any question? Because that's basically the last thing we plan to cover before the midterm. So think of it this way, dependency injection is almost similar to having an abstract class, but the benefit is you don't have to define you don't have to always extend different things. You just say, hey, something will define this in the future lines of code, and leave it at that. So before we leave today, again, usually, as usual, there's an in-class exercise. There's a big, not big, but there's a slightly longer skeleton code on Canvas. It has to do with dependency injection. Feel free to discuss your project idea about what you want to do for a project. This is about almost halfway through the class. Assignment 2 is out. By the time assignment 3 and 4 comes in, hopefully you have some idea about what you want to do for the project. A few of you already told me some of the things you want to do on the project, and it's awesome so far. I hope everyone has some thing that they want to try. If not, I am going to leave an option after assignment 4. I'm gonna post in the last assignment. It will be your project. It's gonna be as equal to your friend's project in terms of difficulty. It'll be more open-end, and you basically demonstrate that you can do something that you learned from the class. The next 2 weeks plan, this is going to work. Okay, what are we planning for the next 2 weeks? Especially October 23rd, that's a holiday. So there'll be some questions about that. October 16th, next Friday, is a normal class. I'm going to do a review session after the class. Everything we teach will not, on that day, will not go into the midterm. It will be the material for after the midterm. We will shift to parallel programming. Your job after October 16, whenever you go through the review session, I hope that there'll be a lot of questions so we can have a good discussion about some of the things we learned. My experience so far after this is, I think, the 4th semester I'm teaching at MUIC, there'll be no questions. There'll be no questions, but then there'll be a lot of questions right before the exam. So that's okay. That's okay. When we go through the review session, think about things that are topics that you might have to go over. Post questions on Canvas, post questions on Discord. Prepare for the exam. Then, whenever you have question on Discord or Canvas, I'm gonna go through this. Basically, I'm gonna reply to you. Then, I would assume that maybe someone else will have that same question. So I'm gonna go through those lists of questions on the makeup class for the 23rd. It'll be noon to 1 p.m. I know that many people might not be able to go to that session. It's the only slot I have on the week, but I'm gonna record it. I'm gonna go through all the questions that were asked after the review session. My assumption is there'll be enough question, and hopefully these are the good review material in case you have the same questions as your friend. The recording will be posted on YouTube channel as soon as it becomes available on WebEx. So these will be on the WebEx. I'm gonna post the link on to how to join those sessions, because WebEx doesn't always allow me to modify the recurring meeting. So I'm gonna create a different link for these makeup sessions. It will be on 22nd, the 20th and the 22nd, Tuesday and Thursday at noon to 1 p.m. Then here's the exam. And now that there's already many people asking about the exam, the format is take-home exam. It's all material up to this minute. Up to this minute and not more. Next to Friday, October 23rd is a holiday and it's a long weekend. So instead of giving you the usual 24-hour exam for the online class format, I would do this. I'm gonna send out the question the beginning of the day on the 22nd. You have until midnight of 26th. Basically, you have 22nd, 23rd, 24th, 25th, 26th, 5 days. 5 days to work on the 24 hours exam. You have 5 days to work on the 24-hour exam. This will be the same length as if you're working on a 24-hour exam. And with my format of 24-hour exams, I will not expecting you to work on it longer than maybe 3 or 4 hours. So pick the slot between those 5 days to work on it. It's open everything, open internet, open textbook, open lectures. Use whatever resource you have at hand. Just don't use your friends or colleagues. So anything that's not human, you can use them. All right. So I hope we all got that handshake that say, don't plagiarize. That's a big thing. Don't plagiarize. Use your own effort on the exam. I will be online on WebEx at some point. I just need to consult my schedule a little bit, coupled with the fact that we can definitely do 23rd, but let's check the schedule because I'm going to release it on the 22nd. And I'm sure that when I release it, many of you would go through the question pretty soon, right? So one way we can do that is after our review session on the 22nd. On the 22nd, we can do this kind of like a Q&A session on WebEx. And then you can ask exam-related questions. This will be live Q&A. Just don't ask me what's the answer to certain questions on your exam. Just don't ask me that because I cannot do it. Additional questions done through email, Discord, and messaging. Any questions about the format? So I hope this is as flexible as possible for everyone. You got 5 days to work on an exam that's designed to be finished within 4 hours. And when I said within 4 hours, I actually it's the theory or and practical. It will be a combination of both. Actually, you will likely get the question on get me a code to do certain things that utilize the concept that we cover. I will make it such that I am aware that not everyone here has taken data structure class. I make that mistake before. I will try my best not to make that mistake again. If you need any additional information outside of what we teach, I will make sure I write a long write-up on how that works. So there will be a mix of theory and practical questions. All right. So that's the end of the lecture. For the latest assignment, is that supposed to be the starter code on Canvas? Oh yeah. Sorry, I forgot. I touched it soon. Yes, I think that is a starter code. I'm gonna put it up. Thank you for that reminder. I would definitely do it.